Okay, so we're going to start the lesson 5 notes. This is all about waves, different types of waves, and different things you need to know about waves. But first of all, here is a wave on a spring. Okay, and with this tool, we can change the amplitude, frequency, all this stuff that we have that I want us to notice. Okay, so before we can play with any of this, we need a little bit of notes. Right, so here we are with a wave. If we increase the amplitude of the wave, we're making it taller. Okay, so that wave is getting taller. If I decrease the amplitude, now it's a much smaller wave. Okay, back to it. Now we need a name for this top, which is labeled a 3, and the bottom, which is labeled 4. So 3, the top of a wave is called a crest. The crest of the wave is the top of the wave. Okay, like the crest of a hill. The bottom of the wave down here at 4, that is called a trough. Yep. So here's the trough of this wave, just like a cattle eat out of a trough. Right, so those are the parts of a wave. You just need to be familiar with the words. Okay. So you can see troughs moving, you can see the crest of the wave moving by. Okay. There's one more thing you should know. It's about frequency. So, how many waves go by in a second? If this is a low frequency wave, a high frequency wave is going to look like this, where there's many more waves. Let me show that to you in the simulator. If we up the frequency, watch what happens. There are so many more waves now. If we turn the frequency way down, it's much slower. Low frequency, high frequency. To low frequency, to high frequency. So in our simulator, the wavelength is from crest top to crest top. So there's the wavelength. If we decrease the frequency, if we decrease the wavelength, that means we've increased the frequency. So what that looks like in the notes is as you decrease wavelength, you're increasing frequency. So we're going to practice this. Now this first one is labeled low amplitude, low frequency. So that means there's not very many waves and they're pretty low. I'm just going to show you what this one looks like. That's what you need to draw. Low amplitude, low frequency wave. Now the next one, the only thing that's different is that the amplitude is higher. So what's going to be true about those waves? Now the next one calls for a high amplitude and low frequency. The amplitude is this height right here. So if we're going to make that taller right there, looks like this. A higher amplitude, but still a pretty low frequency. We're going to go back to low amplitude, but this time we're going to have a high frequency. So here's where we are right now. Low amplitude, low frequency. This is what we started with. What happens if we have a low amplitude and a high frequency? It looks like this. So draw something similar to that. Please ignore these extra marks. Now, if we increase the amplitude of this wave, we take the amplitude up, that's what we end up with. That's our high amplitude, high frequency wave. Okay, so get those drawn in your notes, and we're going to move on to the next page. Now, like I said, we're on this next page, it gets a little more interesting. The sound waves part. Have you ever wondered how sound will travel from my mouth, basically, to your ears? Sound waves. This is like a sound wave leaving a speaker. Here's your speaker. The speaker is moving back and forth. There's a little magnet inside of every speaker, every earbud, everything that's ever made a sound. And that magnet turns on and off really fast and moves a diaphragm back and forth. Okay? And that sends out little tiny shockwave type things. So if you look, you can see these little pulses moving out. But what you need to notice is, look at the little red dots. A red dot is just an air molecule. Is that air molecule moving all the way across the screen? Or is it just moving back and forth a little bit? No, these red dots are staying in the same place. The wave just moves over them. The wave makes them wiggle a little bit. Just like waves in an ocean. The water isn't moving, it's just the energy inside. So this is how sound waves move. Little tiny pressure waves moving out from a source. So sound waves, like we just saw, they are vibrations make air compress into waves. So as the speaker vibrates, the air compresses and those waves spread out and head over to your ear. Okay? The atoms hit each other, transferring sound energy. Here's what a graph of these particles look like. There are a whole lot of particles here, so the graph is high. Then, oh, there's not very many particles here, so the graph is low. Graph is high, graph is low. Lots of particles, not a lot of particles. That's what that's all about. So you need to know how this all fits together. We just learned about frequency and amplitude. Well, low amplitude sound waves, those are really, really quiet sounds. And if you were going to try to draw one, you could say it's a really quiet, low amplitude wave. A high amplitude sound wave, on the other hand, is going to be a very loud sound. So amplitude has to do with how loud or how quiet something is. Amplitude, quiet. Amplitude, loud. How strong they are. The other thing is talking about frequency in sound waves. So low frequency sound waves are really low pitched sounds. Okay? And if you had to draw it, you could put a wave that was really nice and long. On the flip side, high frequency sound waves are really high pitched sounds. So really, really, really high, lots and lots of waves packed together. Onward to light waves. Now, if these waves go out in particles, all right, if these waves are just air waves, light waves are different. Light waves are made by electromagnetic waves. And electromagnetic waves, get this, they're with electrical waves and magnetic waves. That's all they are. Just an electric field and a magnetic field kind of dancing in and out. That's what light is. Low frequency electromagnetic waves, hopefully this is familiar. That's radio waves, that's microwaves. It should definitely be familiar for you. High frequency electromagnetic waves, that's gamma rays and X-rays. I'm trying to tie the word frequency with what you already know. Okay. Now there's two more terms that I want you to know. Okay. They have to do with this word reflection. Okay. A reflection is to bounce off of something. So you guys all have had a mirror and you've all seen light bounce off of that mirror. Now this other word we have Refraction you might not know quite so well. So let me show you a picture that's going to wreck your brain a little bit. So here's a picture. This involves refraction. Okay, here's the person's head, clearly, but it looks like his body's over here. Now, at first you're like, what's going on? But logically, you know that this person who is smiling with thumbs up, his body has to be attached to his head still. Weird sentence to say, but his body is still attached to his head. His body is actually right over here. The light is doing something funny here. Here's a similar picture of the polar bear at the zoo. Okay? Same pool. Okay? This is the most common thing people see, is they see, oh, hey, it looks like it's broken, or it looks weird. Well, you know the pencil has got to be going straight right here. But your eyes are playing tricks. Well, that's the water refracting. Refracting is to bend light around something. So refraction is to bend. As it goes through glass, as it goes through things that have different densities, the light bends. That's the end of the notes. I'm going to show you a few more cool things. You can stay tuned if you want. For example, this is a plane that is going faster than the speed of sound. It's breaking the sound barrier, and you see this cone of condensation around it. I don't really know why, but it's pretty cool. The sonic boom that's associated with this, it's loud enough to break windows, and people thought they were getting bombed when they first heard them.